In this video, I'm going to demonstrate the same division problem, this time using the partitive or sharing equally view of division. For this view, we would have 4, 1, 2, and base 6 things, and we would want to share them equally with 3 groups. And the question would be, how many things do we have in each group? So, in my drawings, I'll have 4, 1, 2 things to share, and then I'll share them equally within 3 groups. Every action that I carry out, the sharing as well as the regrouping, will be demonstrated in one drawing. So, to begin, we have our 4, 1, 2 in base 6 things, and I'll begin by sharing the 36s. I'm sharing the 36s first because I want these drawings to also demonstrate the standard algorithm. And for the standard algorithm, or long division, we work our way from largest place value to smallest. So sharing the 4 36s, I can do so by sharing 3 of them, by putting 1 in each group. That would leave 1 36, 1 6, and 2 1s left to be shared. Now, I've shared as the 36s as best as I can, which means that the next sharing will be done in the 6's place. And before I do that, I'll want to regroup. That leftover 36 is the same thing as 6 6's. So in addition to the 1 6 that I already had, I'll have 6 more. I'll still have the 2 1s. And now if I wanted to share my 6's, of the 7 6's, I'll be able to share 6 of them. And I can do that by putting 2 in each pile. I would be putting 1, 2, 3, 4, 5, 6 6's into those 3 groups, leaving 1 6 left behind as well as the 2 1s. So now each of the 3 groups contains 1 36 and 2 6's, and we only need to share the 1s. But of course, before I can share the 1s, I'll need to regroup. That leftover 6 is worth 6 1s. So in addition to the 2 1s that I already had, I'll have 6 more. And of those 8 1s that I now have, I'll be able to share 6 of them, again by putting 2 in each group. One, 2, 3, 4, 5, 6, and that leaves 2 1s left over. Since we're at the 1s place, and we're stopping at the 1s place, there's no more sharing that can be done. Those 2 things can't be shared any further, which means those 2 1s are my remainder. For my answer then, I can read it directly from the diagram, reminding ourselves of the question being, if we had this many things that were being split into 3 groups, how many things would be in each group? Looking at our drawing, we can see that for each of the 3 groups, each group contains 1 36, 2 1s, 2 6's rather, and 2 1s. Or in other words, we contain 1, 2, 2. We contain 1 36, 2 6's, and 2 1s. For the remainder is the same as before, the number of things that are left over, this time after we've done all the sharing we can, and there are 2 things in the 1's place that are left over, or in other words, the remainder is 2 6. And as far as a mixed number, the answer is the same as before, that for the division problem of 4, 1, 2 in base 6 divided by 3 in base 6, that we would have the answer of 1, 2, 2, and 2/3 in base 6. This time the interpretation would be, if we were to share this many things equally within 3 groups, and if we could share things completely, breaking these into parts, we would have 1, 2, 2 whole things in each group, plus we would have 2/3 in each group. We can see the 2/3 in this picture by imagining me sharing these 1s further. If I wanted to share this 1 with these 3 groups, I would put 1/3 and 1/3 and 1/3 in each pile. And if I wanted to share the second leftover 1 with each group, I would put another 1/3 and 1/3 and 1/3 in each group. That each group would have 1, 2, 2 whole amounts, and 2/3, or in other words, there would be 1, 2, 2, and 2/3 in base 6 in each of my three groups.